Okay, so I'm going to do one of these, and I think it will answer the questions of the couple of people who asked questions over these same types of problems. So first, I'm going to copy this data because we're going to move it over to Excel, and let's notice that we have a small sample size here. It's less than 30 pieces of data, so we want to consider when we have a small sample size, we're going to use the t-distribution. Now, we could use the t-distribution that we have as a file in our course, but instead I'm going to use Excel since we'll be using Excel to find our mean and our standard deviation for this. So I'm going to go to my path. I'm going to go to the little waffle, and actually there's Excel, so I'll open it up and just a blank workbook. And I am going to go ahead and, oh, I didn't mean to hit that. I'm going to insert this data. I'll just paste it. I don't know exactly how many there were, so I'll make it a little bit bigger. Hopefully there were just 12 of them. Let me just make sure I got all of them there. We'll go back here to, oh, not that, to my open math. Were there just 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, 35.8. Okay, is the last one. So that's good. We've got it all. Okay, so let's go back to Excel, and we're gonna go equal average, open parentheses, and I'm just going to highlight all of the data. And you'll notice that it just got the cell names there, and I will close it, and that's my mean. Now let's do the standard deviation in a similar fashion. So equal stand dev dot s for sample. And again, I just highlight them, close that, and there's my standard deviation. All right, so we have the mean, we have the standard deviation. Now, let's go ahead and get for our, and I'm going to go back again to the problem. We need a 99% confidence interval. This is a small sample, so we're going to use the t-distribution. Now, there are 12 pieces of data. So we are going to use 12 minus 1, or 11 degrees of freedom, when we look this up to get our t-value. But first, we have a 99% confidence interval. I will go back to Excel here, and we have got to take 1 minus 0.99. That's 0.01. And then I want to take 0.01 and divide it by 2. And that, of course, is what we do for every single confidence interval, regardless of its size. So we're now going to look up what this would be on the t-distribution. So we need t.inv, and we're going to plug in our probability, 0.005, and our degrees of freedom were 11. And there's our value. We don't care whether it's positive or negative. We're going to use that. Now, I'm going to write these down so that we can go and do these on the page with homework. Okay, so now let's go ahead and we want to find our mean, plus and minus. In this case, it's t of alpha over 2, which was the 3.10581 that we got, times the standard deviation over the square root of n. All right, so let's fill in. We found out in Excel that our mean was 34.98333. I apologize for my slow writing on the screen, but when I'm writing with my mouse, unfortunately, that's kind of the way it goes. All right, and then t of alpha over 2 was 3. That was that last number that we got, 3.10581. Sorry, my dogs are making noise in the background. Standard deviation that we got was 7. 0.163396. Now you'll notice that I'm keeping all of the decimal places, and I will till the very, very end. And that goes over the square root of the 12 in our samples. Okay, um, so now let's go ahead and I'm going to do everything behind the plus and minus. I'll put all of this into my calculator at once and get that answer. Oh, I see. Okay. This draw feature is a new thing. So I was just going to all right, I'll go back. Hopefully it will come back. Oh, it won't. Oh, that's annoying. Okay, that's not so good a thing then. All right, I'm gonna turn this off for a second then. So since it sort of disappeared on me, I just sort of recopied the computation right here. So when I put 3.10581 times 7.163396 divided by the square root of 12 in my calculator, I get 6.42249. So now we're ready for our final calculations. We need to get the lower end and the upper end of our interval. So we need to take 34.98333 and subtract 6.42249. And then we need to take 34.98333 and add 6.42249. So I will first do the subtraction, 34.98333 minus 6.42249. And that gives me 28.56084. I know my points look very small here. And then I'll do the addition. And that gives me 41.40582. Now, let's go ahead and do it in open interval is what it told us to do. And let's see what it told us to round to. Let me go back here and see. Open interval and accurate to 2 decimal places. So I'll go back to my little sheet here. All right, so open interval means we want a parenthesis like that, not a square bracket. And we always, in an interval, want to put the smaller number first. Very important. So we'll put 28.56 since we want it accurate to 2 decimal places. And 41 point, and that's going to round to 41. And that is going to be our confidence interval for this particular situation. So hopefully that will help you get through these problems.